Hey guys, this video here is for these problems 8 through 11 on the test to say write an expression for the new function. So what we have here is we have a parent function, right? We have a cubic. We have some number cubed, we have the absolute value, we're squaring a number, and we're taking 2 raised to some power, right? We have 4 different parent functions. Let's take a look at this cubic here. We're going to move it 2 units to the right, and then we're going to write an expression for that, okay? So let's make sure before we do any of these, we have this general transformation function that you guys have seen. It's been on the board. So let's take a look at it here. And it says this. We have a some number times a function, which I'm going to say some function f. And its inputs, we're going to input some x value, but we can manipulate that x value by adding or subtracting some number. We're going to call it h from that input, right? And remember, graphically, this h value is what gives this horizontal translation, right? Moves the graph left or right because we're affecting what inputs we're putting into our function. Okay, the a, remember, stretches the graph, or what we call shrinks too. Makes it skinnier, fatter, shrinks. Okay, and then we can also take this value, whatever we get, and add some number to it, right? Call it k. And remember that k, just adding or subtracting some number to another value is just going to move the graph vertically, right? So that's how we transform some function. So if we're talking about this kind of parent function, so if I say f of x equals x cubed, then what this would translate to, this transformation function would say a times x minus h cubed, right? H is just going to affect what number we're cubing, plus some number. Okay? So what it's saying is what we have to know is which one of these, A, H, or K, is going to move the graph 2 units to the right. 2 units to the right, horizontal movement, right? So that's our H. So what it says is take our parent function here. If that's the only thing that we're affecting, then we only have x minus, since we're going 3 units to the right, h has to be a positive 3, right? And when we take x minus a positive 3, that just stays x minus 3. And that's why our expression, remember, looks kind of opposite of what we would think it would be when we translate horizontally. So we would take x minus, oh, not 3. Where did I get 3? I'm sorry, 2. We're going 2 units to the right. This is x minus 2, and then we're cubing that number, right? We don't have to add any number k, so we're not going to add anything, right? We're not moving the graph up or down, and then we're not stretching it, so really, we have one of these quantities. Our a right now really has some value of 1, but we don't need to affect that because we're not stretching anything. So this is what our expression would look like, okay? And just to get a visual again, here's what we're doing. Whenever you cube a number, this is just generally what it looks like. You cube a 1, 1 cubed is 1, right? Put in a 2. 2 cubed, we get out 8. 2 times 2 times 2, right? 4 cubed, 4 times 4 times 4, we get out a pretty large number, and it's up off the graph. That's actually 64, right? So just take a number, cube it, and then we can manipulate it by doing all our transformations. So all that we wanted to do was move the graph over 2 units to the right. So I'm actually, oh, there we go. So here's our new graph, right? Here's that just cubing function. So now when we move the graph 2 over to the right, now we have this curve, and if we understand that points on the curve are input-output relationships, we can evaluate this x minus 2 quantity cubed expression for any value we wanted to, right? So there's our expression there. It took our cubic function, this x cubed, and moved it 2 units to the right. So that's our x minus h, or if I let h be 0 again, oops, there we go. And then I just put in my expression. If I just type this, x minus 2 quantities cubed, and I hit enter, there's that graph, right? That's our transform function, at x minus 2 cubed. Okay, let's take a look at the next one. It says take the absolute value function, the parent, so put in some number, just give me the absolute value, put in a negative, we just get the positive value of that number. So the absolute value, say, of -5 is a +5. Same deal if we put in positive numbers, we still get out a positive. Absolute value of +5 is still 5. So that's that V graph that just is what the graph looks like, the curve, the absolute value curve looks like. We're going to move the curve up 1, and then we're going to stretch it by a factor of a half. Okay, so let's see what that looks like here. So let's take this transformation, this general transformation expression basically, and let's look at what that would do for absolute value. So what it says is take any number A, that'll stretch some outputs, and I'm going to take that times the absolute value of x minus h. We can move a graph left or right if we want to, if h has a value. If we don't move a graph horizontally, then h just has a value of 0. And then we can still add some number at the end to shift the graph up or down. So our moving up 1 unit, that's our k, right? That's our vertical translation. So k is going to be a +1 because we're just going to add 1 to whatever number we get out here. And then we're going to stretch this by a factor of a half. So a must be a half. So our expression would just be 1/2 times the absolute value of x. We're not translating horizontally, so -0 or just absolute value of x, right? And then we're moving it up 1, so we'll say +1. So there's our new expression that takes the absolute value graph, moves it up 1, and stretches it by a factor of a half. So let's check that out. So we're going to go absolute value. I'm going to put in our expression here. So I'm going to take 1/2 times the absolute value of x, and then we're adding 1 to it, right? And here's the graph that we get. Notice this point went up 1, okay, but the slope basically has changed, and that's what that half does, right? So that half, if I change my a now to a half, 0.5, then notice what it does to my curve. It now, instead of putting in a 1, getting out a 1, we put in a 1, we get half of 1, so that's 1. Put in, or a half, excuse me. Put in a 2, we would normally, if we take the absolute value of 2, get out a 2, but now we're getting half of that number, so now we're getting out a 1, right? So our slope, as we increase our number, we're getting out half of what we normally would have, and that's what makes the slope slanted like that, right? And then to move the graph up 1, I'm just going to let my k be 1. And notice now my graph has transformed exactly on the expression that we wrote. Okay, number 10 says, let's take the squaring function, right, the quadratic, and we're going to move it 3 units left and down 1 unit. Okay, so again, if we're squaring, we're going to say the a is going to stretch our graph. Since I'm squaring, I'm going to put in my parentheses x minus h. That allows me to move the graph horizontally. We're squaring, so I'm going to square that quantity since it's a squaring pattern. And then we're going to add some number to move it up or down. Well, we're not stretching anything, so we don't have to worry about a. We can leave a alone. A is 1. So we just have one of these x minus h squareds. Okay, but we do want to move the graph down 1, so let's let k be -1, right? So let's subtract 1 or add a -1 to this value to move the graph down 1. And since we're moving the graph left 3 units, then h has to be -3, right? So we're going to let h be -3. So our expression, since a we don't have to worry about, we don't need to write it. We really have a 1 times this, but we don't need to write that. X minus a -3. When we subtract a negative, this is where it becomes +3 squared, since we're squaring, right? That's our function. And then we're adding -1 or subtracting 1. So there's our expression that should take a quadratic, a squaring pattern, and move it 3 units to the left and down 1 unit. So let's try that. So here's our quadratic. Oops, I'm going to get rid of my function here. So here's our quadratic, and I still have set my a to 1, and then my k I'm going to put it back to 0, so it's back to the parent function. So we wrote this expression here. We said the quantity x plus 3 squared, right? Let me make sure there. X plus 3 squared, and then we're going to subtract 1 from that. So when I hit enter, here's what this parent function is going to transform 2, and notice this point here slid over 3 units to the left and went down 1, right? And since the shapes are the same, then it didn't get stretched at all. So we know that h, we said we're going to let it be -3 because we're moving 3 units to the left, and then k, because we're moving down 1, I'm going to let it be -1. And then that will now move our graph right exactly where we wanted it. Okay, and then the last one says 2 to the x. We want it moved right 1 unit, stretched by a factor of 3, and moved up 2 units. Okay, so our general parent function now, since we're taking 2 to the x, says take some number times our 2 raised to the x minus h. So up in our exponent with 2 raised to the x, we have to be able to still have that h affect our x, right? X is just an exponent in exponential functions, and then we can still add some number after. Okay, so now we want to stretch this by a factor of 3, so we're going to let a be 3. We're going to move the graph 1 unit to the right, so let's let h be a +1. And then we're going to move the graph up 2, so let's let k be a +2. So our expression then is going to be, if a is 3, we have 3 times our parent function 2 raised to the, but not just x anymore, it's going to be x minus a +1, so x minus 1, and then we have plus 2. Okay, so let's check that out and then be done with this video here. So I'm going to put in my function now. We had 3 times 2 raised. My exponent is an expression. We're taking x. What are we doing to x? Subtracting 1. And then outside of the parentheses, we're going to add 2, I believe, right? Yep. Let's add 2. I hit enter. Here's what that 2 to the x is going to transform to. So let's make that happen here. So, not cubic, exponential. Here's our base is 2, so here's our curve. We're going to set our a to 3, which is going to just stretch our outputs by 3. We'll make this way steeper. Okay. We are going to translate this 3 units. No, we're going to go 1 unit to the right. So h +1 and then up 2. So there's our graph. All right, I hope that made some sense, guys. Taking that transformation function, just making it make sense whether we're cubing, we're squaring, we're doing absolute value. These a, h, and k's affect all graphs the same way.